Let's see. So we're doing some systems of inequalities,
Okay.
and I have a chapter 1 through 3 test tomorrow,
Okay.
but the main thing is that I'm
Let's
most
go through
concerned about.
at least one problem where they give
Mm-hmm.
two inequalities and you have to graph the solution.
Yeah, there's quite a few of those.
That's the standard problem. So let's go through a few of them, as much as we have time for.
Okay.
So give me one.
All right. I'm just trying to find the sheet that my teacher handed me in class today. One sec.
All right.
No. If I've already lost it, I'm not going to be happy.
No, I could always find some of these or make some up, but
Let's see.
it's better if you find the sheet.
Yeah. Um. Here, I can just go through some from the older worksheet.
Okay.
So, yeah. So the ones that really the ones that are really pretty tricky for me
Uh-huh.
are the ones that have absolute values and the ones that are like and or, and then you have to like shade a certain side of the graph
Right.
and those kind of problems.
That's what I say. If you can find one of those, let's do it, and I'll show you how to do that.
All right. Maybe could you make up a problem that's a little more challenging involving an absolute value sign?
Sure.
Okay.
I'm going to start with, well, I don't know if it's more challenging because I don't know what you're dealing with, but
Yeah.
let's start with this. Let's say you had those two inequalities.
Okay.
You were trying to find the region in space that satisfied both of them.
Right.
Well, let's draw our XY coordinates.
5x minus 2.
If we graph this equation as an equation, what would it look like? Where would we start it? In other words, that's linear, so it's going to be a
So,
straight line.
yeah. So we can just graph each line, right?
Right. In other words, the very first step on these is to really graph it as an equation to begin with.
Okay.
How would
So
you
we can
graph y equals 2x plus 5?
just start at plus 5 and then it has a slope of 2 over 1.
Exactly. So, and is it a solid line or a dotted line?
It is a dotted line.
Correct. So that's what the first thing graphs at. And
All right.
which side of that do I need to shade?
We are going to have to shade the upwards side of that.
Yes. And always talk up or down, not left or right.
Okay.
Okay? In other words,
Yeah, so
y is greater than that. So look to the y-axis, the vertical axis. So all you have to do is find any point at all that's greater than that, like take that point right there.
uh-huh.
That tells you which side to shade. Okay?
Okay.
So I'm shading that side.
Yeah.
All right. Now let's graph the other one and graph it initially as an equation.
So it's just going to have the intercept of negative 2 and then a slope of 5 over 1.
Let me put this a little different color. Is that a solid line or a dotted line?
That one's going to be solid.
Okay.
So that's a pretty straight up and down line.
Yeah. Which side of that are we on?
We are on the bottom side of that, the downward side of that.
Yeah, see, this is the problem with me making up problems. I didn't anticipate that there would not be. Yes, there is.
There's a little triangle of it.
Yes, up there, yeah.
Yeah, right there.
Blue area right there is the place where the two overlap. And that's what you're always looking for. So that is the solution. And this is one of the few areas where I cannot state the solution in one line. I have to state the solution either graphically, like we've done here, or I can state it analytically, but I have to state it like that. That's what that means, is that blue area.
Okay.
Okay? Now, here's where they get more difficult. Say the first equation is this. In other words, in standard format.
Okay.
And the second equation is something maybe like this. Now it becomes harder to graph these because they're not in y equals mx plus b format.
Right.
In other words, the problem I gave you was in this format, which is very easy to graph. And you just have to decide which side of the dotted or solid line you're going to shade. That's all you have to do. Well, if I give you the equations like this, which is probably the way they're giving them to you, it's rare they're going to make it this easy, okay?
Right.
So the first thing you have to do here is figure out how to graph that. And the way to do it is to solve for y. In other words, in this one, we have y is going to be greater than 5 minus 3x all divided by 4, which is the same as 5/4 minus 3/4 x. And now I can graph that. The y-axis is 5/4. The slope is minus 3/4.
Got it.
Okay. And so when they give you the equation of the line in a different kind of format, then the best thing to do is to solve for y and graph it in y equal mx plus b format.
Okay.
Okay. Now, have you located any problems yet? I can make them up, but I never know what degree of difficulty to do.
Yeah.
So
let's see if we can do something like.
And I kind of feel like you understand that whenever they give you two inequalities,
yeah,
that you can figure out what is the area that is covered by both. In other words, what's the solution area?
right. Yeah, I'm pretty good on that part.
I would think. That's what you just showed me. Yeah.
Yeah, I'm pretty good with that. There is this other method that she has us do called for not really graphing.
Uh-huh.
I have the worksheet right here. It's called sign analysis.
Okay.
Have you heard of that?
Sign analysis?
Yeah.
I have not. Tell me what that is.
It's like where she'd give us an equation like, she'd give us an equation like 2x cubed plus x squared is less than 10 plus 11x. And she says there's no way to solve it graphically.
Okay.
So
now I know what you mean by sign analysis.
Yeah, so those are the tricky ones.
Draw a sign chart.
Got it.
Wow. This is not a good one to do it on, though.
Really?
Yeah, and there's a reason. In other words, the only way I can solve this, first of all, when you have an inequality, you cannot ever divide both sides by a variable because you don't know if the variable is positive or negative. Okay?
Okay.
And if it's positive, you're going to leave the direction of the inequality the same. If it's negative, you're going to switch it. So you can't really divide by a variable or multiply by a variable. So the only thing I can do here is to move everything to one side.
Okay.
I can do this. But then I have to factor that. And factoring cubics is not easy.
Yeah.
So, in fact, I don't even know how they would teach you how to do that. Certainly not in relationship to this problem.
This,
Let me change it slightly so I can show you how to do a line chart. Which is
yeah, that's all I need help with there.
Okay. Let me give you this as a problem.
Okay.
How would we solve that? Well, first of all, you factor it.
Yep.
This is a quadratic, so it's easily factored into what?
X minus 5, x minus 2.
Good.
And then
we go down and we draw a line chart because this is not as easy to solve as you think it is. And it becomes a little more difficult when you have something like this. If I had this, say, well, that pretty much requires a line chart. You're not going to be able to solve that without a line chart.
Right.
And when it's a quotient. When it's a product, you could probably figure out how to solve it without a line chart, but let's do the sign analysis that she's talking about. And I actually never heard anybody come up with
with that term for it?
Yeah, a term for it. First
That's
thing,
funny.
when you have the product or the quotient of two things and it's in an inequality greater than or less than 0, the very first thing you want to do is come up with your critical point. Your critical points are what make either the numerator 0 or the denominator 0. What are the two critical points for this inequality?
5 and 2.
Yeah. So let me go over here and mark them. And I really don't want to mark the 0. I accidentally did that. I don't want that on there.
Okay.
Because here's how you do this problem. Any number less than 2 is going to have the same sign on it. So pick a number less than 2 and plug it in.
0.
Okay. What's this when x is 0? And the only thing you need is the sign. You don't even need the number. It's -5. but the key is that it's negative.
Okay.
What's this when x is 0?
Also negative.
Well, negative times negative is positive. What
Oh.
that means is every single point left of 2 is positive. I could plug
Okay.
in 0, I could plug in minus 100. And I would still have negative times negative, which turns positive. Now let's try a number between 2 and 5.
Let's go 4.
Okay, what's this? Positive or negative?
That's going to be negative.
What's this? Positive or negative?
Positive.
Negative times positive is negative.
Negative.
Every number between 2 and 5 is going to give you a negative result. And now let's try a number to the right of 5.
7.
Okay, 7 gives you a positive there, positive there. Positive times positive is positive. Now we're ready to answer this question. Where is the product of those less than 0? Right there.
Right in the middle, because all numbers between 2 and
Yes,
5
right.
are negative.
A negative number which is less than 0. If I change this to greater than 0,
Mm-hmm.
well, now my solution is that and that. So
Okay.
it all depends on whether you are less than 0 or greater than 0. And for doing these, it is important that you have 0 on one side, not a number. So this is a bit like a quadratic.
Yeah.
Now, you might have been able to come up with that solution on your own without a line chart, but where it gets particularly difficult is if I give you something like that. Now, figuring out where that thing is greater than 0, not so easy. You want to do one of these?
Yeah, let's do a harder one.
Yeah, well, this is definitely a harder one. First of all, what are the critical points? That's always the first step.
So each one has its own critical point, the numerator and the
It's whatever
denominator?
makes the denominator or the numerator 0.
So it's going to be -2 for the denominator, and then 3/2.
Okay, now we draw our line chart, and the only 2 points I'm going to plot on here are those 2 critical points. I'm not going to put 0 on there.
Okay.
For a reason. It's not needed on there. And now the only thing I have to do is check numbers to the left of -2, in between -2 and 3/2, and to the right of 3/2.
Okay.
Okay? So pick a number to the left of -2.
-4.
Okay? What's the numerator, plus or minus, when you use -4 for x?
-8 minus, negative.
Okay? What's the denominator with -4?
Also minus.
Minus divided by a minus is a plus.
Oh.
That's the way you do it. And when I write multiple pluses there, that means no matter how negative the number is, it's always going to be a plus. Even if it's minus 100, you'll see that it's minus over minus.
Yeah.
Now pick a number between -2 and 3/2.
0.
Okay, what's the numerator when you use 0?
Minus.
The denominator?
Plus.
Negative divided by positive is negative, so every number inside of there is negative. And finally, usually these alternate. I don't know that I could guarantee that they always alternate, but I've actually heard teachers say that they always alternate, but I actually find that hard to believe. If you start throwing in exponents here, I'm not positive that they always do. So it's always
Yeah.
safe to try all intervals.
Yeah, might as well.
So pick a number to the right of 3/2.
5.
Pick a smaller number to the right of 3/2.
4.
The only reason I say that is you want to make this math as easy as possible.
Okay.
So you actually could pick 2.
Yeah, we could just go 2.
2 makes this math easier. What's the numerator with 2? Is it positive or negative?
Positive.
It's the denominator with 2.
Uh, Also positive.
That positive divided by a positive makes that. And now, because we're looking for solutions that are greater than 0, we're only going to take our positive solutions.
So if my teacher, she likes us to write all of our answers in, I think it's called interval.
Interval notation. Let me write this answer in interval notation.
-infinity to, okay.
With a parentheses or a bracket?
That's just a parentheses.
In combination with is what that U means. And then the right side of it is 3/2, also with parentheses, to positive infinity. So
Okay.
there's your answer to that problem. And interval notation is very useful when you have multiple intervals. In other words,
Right.
if you only have one interval, let's say that was our only interval, then I can say is all x has to do is be less than -2. That would cover this interval right there. But the fact that we have multiple intervals, I can't write it simply, and interval notation is wonderful for that. Particularly sometimes you'll have 3 or more intervals. And so you just connect each one of them with a U.
Okay.
Always starting from -infinity.
Awesome.
So I think that's what you mean by sign analysis, right?
Yep, that's exactly what I meant.
That's an unfortunate term.
Yeah.
You know why?
Why?
Well, because it almost seems like it has something to do with trig.
Yeah, it kind of does.
Doesn't. I mean, because of this word right there. It doesn't have anything to do with trig. What it has to do with sign means plus or minus.
Yeah.
That's what that SIN is meaning, is you're dealing with a sign chart. And a sign chart is a one-dimensional chart like I've done with these. The problem is you're very, very close to getting into trig. You're going to be taking trig next semester.
Yep.
And the sine function is a trig function, probably the most important one you deal with. And so
Really?
when I'm tutoring trig, I always have a problem when I say, what's the sign of the sine? And my first sign means what's the plus or minus sign
Uh-huh.
of the sine function. So
Right.
it's a little unfortunate. The words make it a little more confusing to try to learn. Now, let's make up a slightly harder one. Unless you have a different area, well, we don't have much time. I have an 8 o'clock. So
No, yeah, this is,
let me just
yeah,
mention one thing.
awesome.
If I had something like this. Okay? Now, the
Okay.
first thing you have to do is factor the bottom. Now, what are your critical points?
Now we have 3 critical points.
All right?
We're going to have 3 and then plus or minus 2.
Okay, now we do our sign analysis. There's 3 points on there. And now we have 4 intervals that we have to test. We have to test all points to the left of, or 1 point to the left of -2. Let's go ahead and go through this one. Give me a point to the left of -2.
-3.
Okay, what's the numerator?
Negative.
What's this part of the denominator?
Also negative.
And what's this part of the denominator?
That is, yeah, also negative.
Okay, what's 1 negative divided by 2 negatives? Is that plus or minus?
That's plus.
No, it's minus. In other
Ooh.
words, 1 negative divided by another is plus.
Uh-huh.
But then if you divide by another negative, it's minus.
Oh, yeah.
Okay, which means, okay, so on my sign chart, everything in that range is negative.
Oh, that's, yep.
Now pick a number between -2 and +2.
0.
Okay, what's the numerator?
Negative.
This part of the denominator?
Negative.
This part of the denominator.
Positive.
Now I have a negative. That negative divided by that negative makes them both plus. Now I have nothing but pluses, so that area is plus. Now pick a number between 2 and 3.
2.5.
Top is what?
Minus. That one's
that's plus.
Plus.
Minus divided by 2 pluses is a minus. Now,
and I bet the last one's going to be plus.
Yeah, I think you're right. They may always alternate. I just wasn't aware of that, and I hate to say that and have to come across a function that's more complicated and therefore doesn't alternate. But if I pick a number to the right of 3, like 4, that's plus, that's plus, that's plus. Now, what's my interval where that quotient is greater than 0 in interval notation?
That is going to be, so it's just parentheses, and then -2 to 2, union 3 to positive infinity.
Yeah, you got it. And you use parentheses or brackets depending on whether it's greater than or equal. In other words, if that problem had been greater than or equal, now -2 is a solution, so I'd put a bracket there, and 2 is also a solution, so I'd put a bracket there. 3 is a solution, I'd put a bracket there. And you never put a bracket on an infinity. It's always a parentheses.
Okay.
And that's really
awesome.
It. In other words, the difference between a bracket and a parentheses is similar to the difference between a closed circle and an open circle.
Yeah. Oh, awesome.
All right.
Thank you.
Casey,
feeling good.
Good luck on your test.
Yeah, thank you very much.
You're welcome. I'll talk to you next time.
All right. Talk to you later.
Bye-bye.
Bye.